Why cap is not enough? What is cap theorem and what is PACELC? Like you can pronounce it however, I don't know, but yeah, I will pronounce it as PACELC. So, what is PACELC and why it is said that cap is not enough? What PACELC brings more to the table, right? So, we will come back to this picture, this thumbnail, you would say you will get to understand everything. Like after watching this video you will understand what PACELC is and what is cap. So to understand PACELC, in a short word, PACELC is extension of cap. It brings something more than cap. So to understand PACELC you have to understand cap. So first let's dive deeper into cap and then we will dive deeper more into PACELC. Okay, so let's go for cap. So let me take you. First look at this diagram. What is it is saying? So cap is component made of three components. It is consistency, C for consistency, A for availability, and P for partition tolerance. So let me go through the definition of each. What is consistency, what do we mean by availability, and what is partition tolerance, right? Okay, so here you can see cap theorem states that it is impossible for a distributed system to simultaneously provide more than two of the three guarantees: consistency, availability, and partition tolerance. Cool. So to understand this line, we have to first understand what is consistency. So consistency means all clients see the same data at the same time, no matter which node they connect to. In a lame word, in a simple word, consistency is if some data is there, that data should always be consistent. That data should always be same to all the reading nodes. Cool. If there is any frequent read or write, if there is any new write, that write should be visible, and all the time the data should be there. So this is consistency. It means, you can see it again, consistency means all the clients see the same data at the same time, no matter which node they connect to. So here you can see this is the part of consistency. Now availability, as the name suggests, something should be available. So here in the distributed system, everything is here distributed only. So in distributed system, availability means any client which requests data gets response even if some of the nodes are down. Like if there is some systems, just like you can see there are some, here you can see something like Facebook, Instagram, YouTube, they should be available every time. There can be some data which is stale, that would work. We will come back to this again, but first let's go by the definition, like what is consistency, what is availability, and what does partition tolerance means. So here you can see partition tolerance. A partition indicates a communication break between two nodes. Partition tolerance means the system continues to operate despite network partitions. Cap theorem states that one of the three properties must be sacrificed to support two of the three properties as shown in figure 6.1. This is the figure actually, you can see, right? Now, at any of the time, only two of the components or properties can be achieved. So here you can see there are three type of systems generally: CP, AP, and CA. Here you can see the cross section here: CP, CA, CP, CA, and AP, right? So what is the system? CP consistency, CP systems consistency, and partition tolerance systems. Cool. And AP is availability and partition tolerance, and CH consistency and availability. So it is saying availability while sacrificing partition tolerance, since Network failure is unavoidable. A distributed system must tolerate network partition. Thus, a CA system does not exist in a real world application. So sometimes in the interview questions, they ask about the CAP theorem, and then this is the follow-up question like why CA system does not exist in real world, or which is not possible, CP, AP, out of CP, AP and CA, which is not possible. So you can tell CA system does not exist. Why? Because network failure is unavoidable. So sometimes this can happen. Nodes can be disconnected, nodes cannot reach to each other. So that's why it is said like network failure is unavoidable and CA system does not exist in real world. Now I think till this diagram you are clear, and the basic definition of consistency, availability, partition, tolerance, it is clear to you. Cool. Okay, now let me take you to the diagram. Here you can see this is the diagram for PACELC theorem which I have created. You can see this is the CAP theorem. Till here it is CAP theorem. CAP theorem, what it says, like if there is partition, here you can see if there is partition. Partition means network failure, right? The nodes are not communicating with each other. In that case, remember one thing here, partition, just like we know, like there is partitions in Kafka topics, right? So that is not here. This partition means very much different. This is not the partition like segregating or dividing some part of an element, something like that. This is not something and anything related to Kafka topics or Kafka partitions, right? So this partition is related to network failure. So if there is network failure, which is called partition, then there are two choices. System can either be choose for availability, like it should always be available, or it should be consistency, right? So here you can see the diagram which I showed you. Now come here, CAP theorem. Let me repeat it here. We cannot avoid partition in a distributed system. Therefore, according to the CAP theorem, a distributed system should choose between consistency or availability. So here you can see consistency. Consistency, if you remember, it is the data. The data should be consistent at any time, whether nodes are, and if any node writes some data into it, then that should also always be visible and consistent, right? That should be consistent every time. So here you can see many banking application here in these are the Indian banks. So many banking applications basically they use this consistency model. Basically they need at any time they need consistency. So consistent data. Now if you remember, sometimes we get the message like our bank server is down and we are working some server related issues we are fixing. So there would be 1 hour or 2 hour window for banking apps to kind of, you can say, they are in maintenance mode. So why it is happening? Because they want, every time they want consistent data, right? They are compromising here with the availability. You can see sometimes server is down, so it is not always available. The banking apps are not always available, right? So they are compromising with the availability, but they are consistent at any time, right? Once they are up and running, it would always be consistent. So here you can see MySQL, then Google Spanner, everything. These basically deal with consistency. They always provide always focus on consistent data. Now here you can see availability. Availability is the scenario, as you know, and the system should always be available. So just like social media as Facebook, Instagram, YouTube, Twitter, something like LinkedIn maybe, these kind of social media apps, they are always available. They should always be available. The data can be stale. It is not like banking data, like if there is some update or some write happens on a node, then in that case the data should be available immediately. So that data consistency is not required here in an available system, right? So the system which focuses on availability, it compromises with the consistency. There is a case called eventual consistency. We can, where actually what happens, the data eventually gets updated at some time of a window of a time, something like that, you can say, at a after 1 hour, 2 hour, 3 hour window, the data gets eventually consistent, and it is available to all the media users, social media users. So consistency is not big concern here, it is availability is the big concern. Recently, you remember, recently what happened, YouTube actually got its homepage unavailable for maybe 2 hours. So that was the case where every it became a big news actually. It became a big news everywhere. Articles were written like Google homepage was unavailable for 2 hours. They have not given exact reason why YouTube homepage was down. They simply write there was some technical failure, but they did not tell why this happened, right? So I think you got to understand about consistency and availability. And this partition I told you, here you can see a partition indicates a communication break between two nodes. It's not like the partition of the different topics in Kafka, something like that, right? So what cap theorem says, now let's go back to diagram. What it says, if here you can see if partition happens, that is if network failure happens, then yes, then what is we have to choose, we have to choose between availability and consistency. This is what our cap theorem is in a nutshell, right? I hope you got it till here. So this is very simple, this cap theorem. Now I think you got. And I told you, like, there is, if you remember, this AP, CP and CA kind of availability, these systems, if you remember, these systems here you can see is consistency and partition tolerant. It says like a CP key value store support consistency and partition tolerance while sacrificing availability. Don't go into this much, just understand like consistency and partition tolerance, these could happen together, as in the diagram here I can show. If partition happens, you can go for availability, right? So this P and A, this partition P and A here in red color. So this P and A makes an AP system, right? So here you can take, here you can understand it is a AP system. So let me write it here, it is AP system. And here you can see a CP system, which is CP. So it is similar to this diagram. Here you can see this is CP system, this is AP system. Availability and partition tolerance and consistency. So when partition happens, this is the scenario, like when partition happens, that is network failure happens, in that case only we can either choose consistency or availability for a system, right? Distributed system. Cool. I think it is self-explanatory now. Partition tolerance, remember the partition tolerance and also remember the diagram. From partition tolerance, if partition tolerance happens, sorry, partition happens, then consistency or availability. What is here partition tolerance? Tolerance is the ability to respond in case of network failure. So tolerance is like even be available, how network basically how system respond when there is network happens. So partition tolerance is the ability to tolerate, actually tolerate, like when network failure happens, then how system responds. So system should be partition tolerant. Sometimes it is said like this system is partition tolerant. What does it mean? Like if network failure happens, even then it can communicate, it can communicate and respond in some other way, right? So this is partition tolerance. So Generally we are dealing with we are talking about partition, not partition tolerant. So remember, when partition happens, like network failure happens, then we are going through these things like these systems. Cool. So if partition happens, we can choose availability, then it is AP system. If we choose for consistency, then it is CP. So here, now come back to this diagram. Here you can see consistency and then availability. So if partition and availability are together, then it is AP system. And if we choose for consistency, when partition happens, then it is AP system, right? Till here I think you are clear. So this is our cap theorem in a distributed system. I think you are till here you are clear. Now let's understand what PACELC theorem provides extra. So when there is a breakdown, there is network breakdown, when partition is there, like there is no communication between the nodes, in that case we can tolerate and we can choose for availability and consistency, right? Any one of them, like AP system or CP system. But if there is, suppose there is no network failure, like there is no partition, everything is good, everything is fine. If there is no partition, there is, in that case what happens? PACELC theorem said if or else. Here in example, sorry, uh, in the name actually PACELC, you can see P is for partition, this one, and then A is for availability, this one, C for consistency, E for else. Here L for latency, and C for consistency, which I also have here. You can see, we can go for here, you can see PACELC, everything, their acronym and their full definition here you can see, right? Cool. We will come to this also. Let's first understand the diagram. So it is saying if partition happens, then we go for availability and consistency, which is cap theorem. Other than that, if there is no partition, then what we can do, we can, there is two trade-off. We can either choose latency, like faster system. Latency means faster system, like latency, like the time taken from client to a server. So this is latency. So here also you can see in this diagram I have here mentioned here, like what is latency. You can see here from client to server the time taken is 1 millisecond. So it is called latency from client to server, and coming back to client, it is called latency. Okay, so we'll come to this also. First let's go here. So what it is saying, if there is no network failure, there is no partition, then what we can do, we can choose a system for latency, better latency or better consistency, right? So this is our PACELC theorem. This extension, like if there is no partition, then what happens? We can choose latency or consistency. So remember, this partition is the center. Partition is everything here. While understanding cap theorem or PACELC theorem, first remember this diamond shape partition. From here the definition goes, like if it is yes, then availability or consistency. So this brings to our cap theorem. Otherwise latency and consistency are added extra, and that extra entirely it makes, you can say, this entirely makes PACELC theorem. So you can see here this entirely is a PACE theorem, basically your where is opacity? You can make it 0%, right? Cool. So I think you got it till here. So entirely this is our let me take it back. This rectangle I was trying to draw here. So everything is PACELC is this cap theorem plus your extra part of this latency and consistency. Cool. Okay, now let's go here. Here you can see PACELC theorem. It is saying simply what I have told. It is explaining that PACELC extends cap by adding a trade-off even when there is no partition. It says if there is a partition, choose consistency or availability, which is your cap theorem. Else, choose latency or consistency. So PACELC formalizes four trade-offs. Scenario is like during partition, consistency or availability, no partition, latency or consistency. Just the same diagram, right? Here up this one. If yes, go for this. No, choose latency or consistency. Like here you can see during network partition what happened. Distributed systems must decide. Distributed system must decide what they should decide. They should decide consistency guarantees all nodes have the same data, and availability serve requests even if they can't be consistent, which I already told, right? Example, here you can see CP system prioritize consistency. Here for example MongoDB and HBase, and AP system prioritize availability like DynamoDB, and you can see here Cassandra, everything. I have also here yeah, here you can see MySQL, and then Apache, Google Spanner, MySQL, here Oracle, everything, and Apache Cassandra I missed, I think, right? So here it would be like consistency part, right? And when there is no partition, then system should choose between latency, that is respond fast. Latency is respond fast. Here you can see latency and consistency, so it can choose either latency or consistency, like same data. Cool. So trade-off examples are here. You can see low latency eventually consistent, read from the closest replica. This way it can save some time. And high consistency but slower, require quorum or leader based reads. So this is another big thing, quorum and leader selection, everything. So we will not touch this into this video, but yeah, you can remember, like if there is consistency is important, then we can compromise with the time, like latency. Okay, so example, you can see some of the examples which I have here, like Cassandra. There is system cap and then PACELC class. So here you can see Cassandra is an AP. By cap theorem it is an AP, but by PACELC it is PA/EL. So let me tell you how to understand this PA/EL. What is this slash doing here? What is the meaning of slash, and then two letters before it and two letters after it? So what is it? It is like P is partition. Like if partition happens, like if there is network failure, which is partition. If partition happens, in the diagram, look here, it says everything in the diagram. If partition happens, then availability. If partition happens, then consistency, right? Else latency, else consistency. So let me go again there. Here you can see P and L. If partition happens, choose availability. So PA is if partition. Here you can see PA is if partition happens, then availability. Then there is slash. Slash is else part. Else, what is saying after slash? It is saying E is for else and L for latency. So else, choose latency. Prefer availability and low latency, right? So here else part is after else. You can see here in the diagram it is latency. I think you got it. I am repeating myself very much, but it is important to understand this syntax actually. PA/EL. See here in the same way it is PA/EL prefers availability and low latency. Partition, if partition happens, P is if partition happens, then choose availability, or else everything is fine. If there is no partition, choose latency. Here in the case of HBase, you can see it is a CP system. CP system, like consistency is very important here. So in case of PACELC also, if there is network failure, choose consistency. If there is no network failure, then again choose consistency, because These are HBase is kind of, these are used in banking system, so they prefer consistency. Like, and here a new term is here, Cosmos DB typically PC tunable consistency. So we are not going into tunable consistency, but yeah, you can understand these things, right? Cool. So here by summary you can see cap partition, choose consistency or availability, and PACELC, C versus LCLC, something like that, right? I hope you got it. Like, it gives what PACELC does extra. It gives latency, or it gives freedom to choose for latency or consistency, right? So here C versus A, else L versus C. This gives a complete model for distributed trade-offs. I think you are clear with the cap theorem and PACELC also, like what extension. So partition is the gold mine here. You have to understand from partition everything goes up or down. Cap theorem and then PACELC extension, right? Cool. I hope you are clear here. In this diagram also you can see PACELC is explained, like the PACELC theorem states that in a system that replicates data, if there is no partition, which is P, a distributed system can trade off between availability and consistency. If you remember, if partition happens, then availability and consistency, it is same, the same diagram, right? If partition happens, consistency and availability, right? So this is cap theorem. So part first of this PACELC is cap theorem, and else, that is the extension part. Else what we need to do, we need to choose between latency and consistency, which is written here. Else, when the system is running normally in the absence of partitions, the system can trade off between latency L and consistency C. Cool. So I think you are very much clear with cap theorem and PACELC. Thank you very much for being here. Let me know in comment section if you have any doubts, any new concepts you want to learn. That's all. Have a good day.